Hello and welcome to our Expert Insight video series. I'm Chitra Sethi, Editorial Director at SA Media Group. As embedded systems in safety critical industries become increasingly complex, the demand for reliability, security, and maintainability has never been higher. Rust, coupled with the qualified Ferrocene toolchain, is poised to meet this need. Joining us today is Florian Gilcher, Managing Director and co-founder at Ferrous Systems, who will discuss the benefits and challenges of Rust adoption. Welcome, Florian.
Hello, thanks for having me.
So, Florian, how are regulations shaping software practices and why is Rust gaining traction?
I think these two things go hand in hand a little. I'll start with the second part first. Why is Rust gaining traction? There's an increased desire in software stability, but also in efficiency. And Rust has arrived at the right moment to present a programming language that is both energy saving, efficient, close to the metal, as people say, but is very much on the safe side of programming. So you can't do any accidental, nefarious things with the language and open up security holes. Regulation is kind of a counterpart to that. So what we're seeing is because regulators, first of all, are looking more at software. Software bugs are becoming an increasingly bigger problem at a grand scope, even at a national scope or an international scope. And so they're looking at what the current baseline of technology is, and they're saying, oh, we're now seeing that even in tiny devices, memory constrained devices, there's now solutions available that are as safe as things that we are using on the servers for like 20 years. So why not actually mandate that those solutions should be used, or that if you're not using them, you're at least putting equivalent checks in place that you're raising your quality bar to at least that level.
And how does Rust support secure software supply chains?
So Rust is more than just a programming language in the sense that when it was constructed, it was not only just the compiler tooling, but also the whole tooling around it. It comes out of a generation of programming languages where management of, for example, all of the libraries that you're using is part of the scope. So Rust comes with tooling, for example, there's a tool called Cargo that manages all of your dependencies. That means you have a whole list of what you're depending on and can then, for example, do additional vetting on them. And the whole language and the whole tool set is aware of that process and can do cross checks between all of those libraries and see if calling from this library into this library properly works. So it has this whole picture in mind. And additionally, it comes with, by default, with tooling that is usually third-party tooling in languages like, for example, C and C++, where there's, for example, a tool shipped with the Rust compiler called Clippy that will check your code for example, patterns that could be improved, or where there's a better pattern available, or where there's a more performant pattern available. The thing that's usually called a linter. One thing I have to say, though, is this talked about C and C++. One of the things is that this habit of Rust shipping a whole toolchain is actually now something that is also coming up in the C and C++ world. So, for example, LLVM also ships such warnings and checks with it for C and C++.
Got it. And Rust is often coupled with Ferrocene. What is Ferrocene and why does it matter?
So Ferrocene is the toolchain that Ferrous Systems ships, which is completely based on the Rust compiler toolchain, the one that the Rust project ships, but with additional work being done on it to do a so-called qualification, which I always describe as this is a process of making sure that your gut feeling that you have something that is safe and good to use is actually correct. So the standards, I always say, like, they serve as an inspiration and also kind of as a mandate to make a case for, okay, the Rust compiler is well tested. It actually does what it claims. And this is how you deploy it safely in an industrial setting. Because there are features in the Rust compiler that, for example, very rarely exhibit bugs. So to take one of them, the Rust compiler has a speed optimization that is called incremental compilation, which means that during development, you don't need to recompile the whole program all the time. You can recompile it in slices. This is something that is sometimes introduces subtle bugs. During development, that doesn't matter. It's incredibly rare, and usually your program crashes. But it is still useful to say, in a safety-minded environment, please make sure if you do the final build that you don't do it using incremental compilation. So it's also an exercise in informing the user what the tool actually does and what this option is there for. It's just there for development. It's not there for your final for your final deployment. It sounds so easy, but one of the problems is that programming language tooling is incredibly complex. So it's very useful in these kinds of settings that someone has written down, hey, these and these and these and these and these things are generally high quality. But if you want to be actually paranoid, don't do this, do it like this. Yeah.
Thanks for explaining that. How does Rust benefit developers and teams?
So Rust is a more rigid language, and that may sound a little bit more counterintuitive. So it comes out of a drift that we've seen in the recent years that languages get stricter. They don't give you that many options anymore. So they tell you, hey, this is the way we do, for example, handle memory. This is the way we do I/O and things like that. The reason why that happens is if everyone has total freedom, you get a problem if you have 20 artists trying to build a coherent and sound program. So it comes out of that lineage. But on the other hand, so now you have the system that's a little bit harder to use and that has more rules around it. But the good thing that Rust has done is then that comes back to the tooling. It tries to give you very good advice on which direction you go if you, for example, confused. If you made an error, the Rust compiler will usually tell you this is an error. It will not fix it for you because that may introduce subtle problems where you're disagreeing with what the compiler is actually saying and so on and so forth. And but it tells you, hey, by the way, have you considered doing this? Is this what you wanted? So there's a counter drift to we're now working in a stricter system that is easier to analyze and easier to grok once you understood it. But on the other hand, we have tooling that tries to make it as nice as possible for you. So there's quite a lot of thought that went into making the Rust tooling, well, one of the best in its segment.
Got it. And what does Ferrous Systems offer to organizations interested in adopting Rust? And which industries do you typically work with?
Okay, that's a broad question. Let me take a step back. I started training Rust personally in 2015, so 10 years ago. And Ferrous Systems comes out of the observation that in the first 3 to 4 years, that was a nice side business for me personally, next to my old company. But in about 2018, a lot of people came along and had actual serious projects they wanted to build. And so we were like, okay, there is a need for a company that helps other companies adopting Rust. And that's how we formed Ferrous Systems. And that was kind of like the early mission statement. So for those couple of years, the environment being new and the needs changing all the time, that was basically training and consulting and tools development. For example, we built the current Rust IDE, Rust Analyzer, and make sure that that is improved all the time. So that was kind of a phase where, to be blunt, like the customers didn't quite know what they need. So there was more sensing into, you get a call with someone who says like, I heard about this Rust thing. What do we do? And then you figure out what the service is. So it was really flexible company back then. Nowadays, that has structured itself more. So we can now do the whole set between training, consulting, but also tools development and actually tool shipping. So we have all of these segments so we can help companies with everything they need. We're going a little bit back on the classic consulting where we're basically people for hire that join your project. But for example, a classic way on how we're dealing with companies that adopt Rust is an initial training first, and then an assigned engineer who helps you succeed in your project over the next couple of months. So you'll have a weekly or twice a week call, checking in on problems. The one thing that we're very focused on is we want to enable people to do Rust by themselves. So we're not the company that you would hand things over all the time, and then, well, in the end, you'll get a block of 20,000 lines of Rust, and you don't know what to do with it because you don't have the engineers for it. So we're really in the business of empowering companies. That is still changing every 1 to 2 years of what the actual need is. And it's going quite fast. We're 6 years old, and 3 years in, a customer came to us and said, safety qualified compiler, we have a real need for that. Could you build that for us? And we're like, okay, yeah, safety critical compiler, let's do that. On your second question, which industries are adopting Rust? All of them. It comes in waves. Very early on, between 2015 and 2018, it was all over the place, but kind of niche. From 2018 on, which is kind of the inflection point where Rust became a mature industry accepted language, it was adopted. And basically all hyperscalers, Google, Amazon, and Microsoft are big supporters of Rust and are using it heavily internally. But also small companies, startups, quite a lot of AI systems nowadays. Back then, quite a lot of blockchain systems are written in Rust. So it's really hard to say which industry doesn't do Rust. It's much more these industries that are a little bit more conservative and slower in their adoption phase. And then there's places where there's just still so much work to do within Rust where people are not sure if they can adopt it yet. I give an example. GPU programming in Rust is more of a niche thing. There are people who are doing it, but it's currently not the focus that the language is being built for or that the Rust project is building that language for. I totally love to change that. I'm talking to people about that. But this is just a wall that you must climb over before the language is just usable for everyone, except just someone who's really interested in GPUs and really interested in putting Rust on GPUs. So that's kind of the thing where it decides itself on. Less on the is Rust capable, theoretically capable. It's practically, is there tooling around? Are there libraries around? And same thing, coming back to Ferrocene, is like for a lot of people who do safety critical, or all the people who do safety critical, the availability of a qualified Rust compiler was just a thing that was strictly necessary. And now that they're available, now you can see it blossom in all of those companies. Basically, every company I speak to nowadays does Rust somewhere, every larger company.
Fantastic. Yeah, it looks like there is a learning curve involved here, which is where the companies are slowly getting into, and I guess Ferrous Systems is helping them.
There's actually one thing I'd like to address there. Rust, so a lot of people say Rust has a learning curve and it's a little bit out. And I think that's important. If a new programming language were an incremental increase, say it's 5% better, it would not have a chance of being adopted. Because essentially when you're saying, do your new development in a new programming language, or even rewrite some of your existing software in a new programming language, you are asking people, the image that I'm always using is you're asking people to knock down one of the houses in the street and rebuild it. People do that all the time. It's a common thing, but you don't knock down a house just for the fun of it. And you would certainly not knock it down if you could build a 5% better house. So it is actually important that the language is stepping away from what the preceding languages did, because otherwise that step would not be worth it. So I'm not saying we should make it easy. That's what we're giving training for, and so on and so forth. So we'd like to help across. But it's actually important that there is a larger step that you need to take, because otherwise just fix your old tooling. Incremental improvement can just be based on what you're doing all day anyways.
Fantastic. How does Ferrous Systems help the teams succeed in regulated environments?
First of all, by shipping tooling that is pre-qualified. But the other thing in regulated environments is there's often very detailed questions on how the tool that you're using works, or the language that you're using works, or you need something fixed or implemented in a very strict manner. And this is what we're helping with. So there's a point where teams need to deliver their software, and that's often not necessarily we need to know all the details of the programming language that we're building it in. But in the end, those details matter because you don't want to run into any kind of problems. So The way we're helping is any kind of knowledge transfer through writing documentation or through pre-testing things, which is essentially, hey, these are the tests that have already been done for you. It's also a kind of knowledge transfer. So we help in all the corners where you don't have an expert around, because in the end, Rust expert is not really a job if your job is building a medical device. Your job is being medical device engineer. So we see our role of basically being your Rust expert sidecar that says, okay, this is how you do it safely. We can review this. Programming languages evolve and young programming languages evolve. So even refreshers like, yeah, this was something that people did 2 years ago, but because the compiler got better, the tooling got better, this is what you're doing in, say, 2027. Talking about this. It's a whole bouquet of services that we're giving there. Sometimes it's even, which hardware do we pick? What is good support? What is well supported? What is not well supported?
Got it. Finally, what advice do you have for companies interested in Rust but worried about adoption challenges?
Start now. The thing is, if you are convinced that Rust is a technology that will be introduced at your company eventually, be it because you want it, or sometimes because it's forced on you. This is actually something that has been coming up in the last 1 to 2 years, where people are saying, our customer insists on implementation in a memory-safe programming language we can't use C. We need to figure out how we do this in Rust, things like that. That's kind of a forcing function. If you think that Rust will be something that ends up in your company in the next coming years, start working on that now, because otherwise you'll be under pressure the moment you actually want to deploy this. So say the actual inflection point is 3 years out. Now you have 3 years of starting slowly, maybe having someone implement a small tool or something like that, like build internal experience, while in 3 years you're on a rush. You need to hire external folks and so on. In general, well, start now is my big recommendation, because that allows you to start slowly and on a gradient. And this is actually, there's a great talk at RustFest 2019 on how Microsoft adopted Rust. And this is now a common engineering industry adoption. The moment you got the hunch, start small investments and see how you can work with that new technology. It's not go all in.
Yeah. Excellent. Well, thank you for your insights, Florian, and thank you for joining us today.
Yeah, thank you as well. Thank you for having me.